Hello, good evening. Dear friends, we can start the meeting.
Yes, sir. A very warm welcome to all the participants to another engaging session of our 1 week hands-on workshop uh, on Python essentials for artificial intelligence, machine learning, and data science. Over the past few weeks, we have built a strong foundation in Python programming, data analysis, and data visualization. Today, we take the next major step by entering the fascinating world of machine learning, where computers learn from data to make predictions and informed decisions. Just a minute. Okay. Today's session will introduce us to the to the core concepts of artificial intelligence, uh, AI, machine learning, and deep learning, helping us understand the differences and how they work together. This session will further cover widely used machine learning algorithms, including linear regression, logistic regression, decision trees, and KNN, along with essential model evaluation metrics such as accuracy, precision, recall, F1 score, and confusion matrix. To reinforce these concepts, we'll work on hands-on projects involving iris classification and house price prediction, giving you practical experience in building and evaluating machine learning models. Machine learning is transforming industries such as healthcare, finance, education, agriculture, and business by enabling data-driven decisions and making and intelligent automation. The knowledge and practical skills you gain today will serve as a strong foundation for your journey into artificial intelligence and data science. I encourage everyone to actively participate, code along with the demonstrations, and make most of today's hands-on activities. Practical implementation is the best way to understand how machine learning algorithms work and how they can be applied to solve real-world challenges. It is my pleasure to welcome our esteemed mentor and speaker, Dr. Meher Chand, whose expertise in AI, machine learning, data science continues to inspire learning through his practical, research-driven, industry-oriented approach. With great pleasure, I invite Dr. Meher Chand to kindly lead us into today's session. Over to you, sir.
Thanks, dear friends, for the nice introduction. And dear participant, welcome back to our ongoing workshop. And today is the fifth session. And the topic which we are going to start is very interesting, very useful for the machine learning model. Is This is the part of our content module. Okay, so some of the part related to the statistical analysis or we have discussed in the past four lectures along with the Python concept which are essential we have covered. Okay, so this is the 1 week workshop and you will have the just ideas how you can do and which type of the essential skills are required for the machine learning model. Okay, so whether you are very beginner or working professional in the machine learning has become one of the most important technological driving innovation across every industry, from healthcare, finance to agriculture, cybersecurity, education, and intelligent automation. Machine learning is transforming the way to solve real world problems. So today our goal is not only to understand the theory behind the machine learning, but also to gain practical insight into how the machine learning models are built and applied using the Python. Throughout this session, we will start from the fundamental and gradually move toward hands-on implementation. And by the end of today's lecture, you will have a clear understanding of the complete machine learning workflow. Okay, and to prepare the data, to building predictive model, and to evaluating the performance. So our goal is what are the steps are required, which type of the techniques you are required. Okay, so as on the right hand side, you can see here data pre-processing, feature engineering, regression, classification, model evaluation, etc. Okay, and the hands-on will be just like linear regression, logistic regression, decision tree, care nearest. So these are the algorithms which we can apply. So this is the just overview about what we are going to cover. And after completing this lecture, what you will gain. Okay. By the end, you will get how understanding about the artificial intelligence, machine learning, and deep learning. You will be able to differentiate between the supervised, unsupervised, and reinforcement learning. You will be able to perform data pre-processing and feature engineering, which are the very essential part. Okay, and separate the data into training. Actually, when we have the data set and we want to develop some intelligent model, okay, we have to split our data in two parts. One is using for the training and other is for testing. Okay. Then after we have to build the regression and classification models. There are several models which we can use one of them according to our need, and we have to require to test whether the model is returning the accurate outcomes or not. Okay, we have to check the accuracy. So there are some parameters and tests are available. By using them, we can check the performance of the model after developing it. Then we evaluate the machine learning model using the standard matrices. Okay. And after that, we have to implement the machine learning algorithm using Python and scikit-learn. Scikit-learn is a library which contain all type of the machine learning models. Okay. So this is very essential. And after that, solve the real world prediction and classification problem. So this is all about it. And actually, if we talk about artificial intelligence, this is a very broad term. But here we are going to talk about machine learning, which is the subset of AI. Okay, so for that we are required some data set, and by using the history data, we can develop the model, and after developing it, we can predict the future value. Okay, deep learning also the subset of machine learning. Okay, which is based on artificial neural network, CNN, RNA, etc. So for that, we are required some more advanced techniques, and we are required to understand about the concept of what is actually artificial neural network. That will be covered in the coming sessions, but I'm not sure I will be able, because the duration for this workshop is only 1 week. And for this, there is a one workshop was going on, which is for 45 days. But have, in that workshop, we easily cover all the concepts which are essential. So the content which we can cover in the 45 days, we are not able to cover everything in 1 week. Okay, so at least what is machine learning model we can cover here. Okay, so here this is the introduction of the machine learning. What is exactly machine learning? It is the branch of artificial intelligence that enables computer to learn patterns from the data and make prediction without being explicitly programmed. Okay, so in that case, instead of the writing the fixed rule, machine learning algorithms which we are using here, which we are going to use, learn from the historical data. Okay, so the algos which are helping to learn to train the model, but for that we are required data set. So as much we have the large data set, we have more accurate outcomes. Okay, so this is the procedure. First, we are required to collect the data. Then we have the data pre-processing. The pre-processing mean to check the mixed value. Okay, to check the null values. If there are duplicate values, we have to remove them. Okay, and duplicate values and missing values. So there are some just like processor to clean the data and pre-processing the data. Then we have to apply when the data pre-processing is complete. then we have the learning from the data. So at this stage, we have to use some algorithms. And by using the same, we have to train. And once the model is trained, then we can use the model for the prediction for the future value. Okay, so here you can see the examples, just like email spam detection, face recognition, recommendation system, fraud detection, medical diagnosis, self-driving cars, chatbots. Okay, so these are the examples where we can apply machine learning models. Okay, so the main here is model is trained from the data set, and data is labeled data. Here is the term. Okay, this will be in the next. In the case of a historical data, it means we know the output value. Okay, when we know input as well as output. So this is the labeled data. Okay, just like see here in the next slide. So these are some categories, AI, ML, and DL. Okay, so as we talk, AI is very broad term. Machine learning is the subset. Deep learning is subset of machine learning. We are going to cover machine learning. Okay, because this is completely based on the data set, and we are working on data right now. So if we can compare, comparison is given here in 3 columns. So in the first column, we have the AI. In the second, we have the machine learning. Last one, we have deep learning. So if we observe the definition, okay. So artificial intelligence is completely based on make intelligent machines. Okay. And when we are using machine learning model, so this learns from the data set. Okay. And in the deep learning, learns using the neural network. So just like biological neurons, just our brain is working. So on the basis of the same model, we have the artificial neural network. Okay, so how the neurons are working in our brain, the inputs are taken, then there are hidden layers. What are the calculations our brain is doing? We don't know, but we have the prediction. Okay, we can have some output. Something is happening according to our observation. Okay, so in the same way, when we will use here artificial neural network, so input will be there, then bias is there, so machine function will be there, that will calculate hiddenly. We don't know what type of the operations will be there. So all these will happen in the hidden layers. Then there will be the activation functions. So the neurons will be activated by activation function. All these are the mathematical functions. Okay. So after that, we have the output. So this is the process in the deep learning, which is completely based on artificial neural network. But this part, which is the machine learning, we need only the data set, and we all can easily develop this technique, and you will do. Okay, you will do this part yourself, and one model you have to submit. But how you can do, I will let you know. Then you can see what is the relationship between these. So this is the broad field and subset of AI, and this deep learning is the subset of ML. And what are the approach? This is the rule-based plus learning. Okay, we have to have to define, and then we can train the model. But here we have only the data driven. From the data, we are training the model. And here we are required large data set. Okay, large data and driven. Okay, then techniques. This is the use the logic and reasoning. But here we have the algorithms. So by using the algorithms which are existing, we can easily train the model. Okay, and here we have the deep neural networks. And the examples you can see the chess AI. Okay, and we all observe, we have seen the AHS. Then you can see house price prediction. So for that, we are required only the data set. And here is the image recognition. Okay, for that we have the deep learning concept is required. Okay, so large data set is there, okay, in the form of the images, and from the images we are training the model. Okay, the images as compared to numerical value, the size is very large. Okay, so these are the some comparison between AI, ML, and DL. Just overview. So these are the three types of the machine learning. One is the supervised learning, second is unsupervised learning, and third one we have is the reinforcement learning. Okay, so here you can see we have the labeled data. What is the meaning of the labeled data? If we have the input, there will be output. Okay, so this is the labeled data because this is the completely historical data. And if we see the historical data, so all the parameters, independent as well as dependent variable will be there. Okay, if these parametric values are there, and on the basis of these parametric values, we have this type of the output. Okay, so this is the way the input and this is the output, and in between them, there will be some machine learning model. And by using the machine learning model, we will train on the basis of input and output. Okay, the data will be divided in two parts. Okay, 20% ratio, 80-20 ratio. Okay, so there are several algorithms just like linear regression, logistic regression, decision tree, random forest, KNN, SVM. So one of them we will use for the machine learning model, but we have to check the 2 or 3 model, which model is giving us more accurate value. And if we see the examples, we can use for house price prediction. We can use for student marks prediction, disease prediction. Okay, so these are the supervised learning. And keep in mind that data will be labeled. Okay, and in the case of unlabeled, unsupervised learning, we don't know about output. So we have only these values. Okay, this part is missing. Then output is not, there is no output. So this type of the data when we have the hidden, our goal is to find out the hidden pattern. What are the pattern inside the data set? And this type of the data set is known as unlabeled data when we have no output. Okay, for example, customer segmentations or market basket analysis. Okay, so these are the examples. Okay, and these are the algos which we can use for unsupervised learning, just like K-means, hierarchical clustering, PCA. So these are the algorithms, and by using this algo, we can have segmentation. Okay, we have the clustering. Okay, of the clustering means in the different groups. You can see here the data are in 3 groups. Okay, separately. Okay, so just we can find out the pattern, and when from the entire data set, when we have some new input, so that automatically according to the 10 model and which pattern is match, this will give the prediction. Okay, so the unsupervised learning finds the pattern and structure in the unlabeled data set. And last one we have is the reinforcement learning, which is completely based on environment. Okay, so from the environment, many times when we do some mistake, whether we are teaching, whether we have the official responsibility. Okay, if we do something good, then we have reward. And if we do some mistake, then we have penalty. So from the penalty, we learn some new thing. If you do in this way, and we will remember the penalty. Okay, this is the dependent upon the environment. Okay. Oh, and agent will automatically, agent is something algo which we are using. Okay, so this will update many times when we check any model, it's like you can say weather prediction. Okay, or any which is the model which you are using some type of the testing. So there is a symbol like or dislike. Okay, in the very beginning, the weather prediction model was not too much accurate as now. So the model trained itself from the penalty. If the prediction was accurate, then we praise thumbs up. Okay, if there is not accurate, then we have the negative response. Okay, so this is a very simple example for the reinforcement, and the model is trained based on mistakes, errors. Okay, so we can use this type of the model for robotics, games, autonomous vehicle. Okay, so this technique is used there. So this is the overview about the different types of the machine learning. But when one thing is common, all these three, whether it is supervised, unsupervised, or reinforcement learning, we have some data sets. Okay. So the thing is here learn by trial and error. So this is the meaning of what is the machine learning. Now we have some more interesting part. We understand the types of the machine learning, but how you will train the model. Okay, this is the very next level. So first we are required data pre-processing, and some of them operations which are required we have done. Okay, see here, when we get some data set, okay, you collect a data set from anywhere, that is primary. Okay, so some values will be missing, duplicate entries we can find, we can have the incorrect data, there will be some outliers, okay, there will be some noise. So first in the raw data, we have to remove all these. We have to clean the data set. So this type of the operations which we are required to implement is data pre-processing. Okay, so the main purpose of data pre-processing is to clean the data set, to prepare the data set for statistical analysis, for to implement any machine learning model. Okay, so these are the common steps. Okay, these are the steps which we are required to implement. First, second, third, four, five, six. And all these are required one by one. We will discuss one by one. We will implement, and some of them we have used them. Okay, see the important input data sets. First part is the data set can be in CSV file, Excel file, SQL file, or API URL we can have. So just like we have the example to use the CSV file. Okay, so this is the way we use this statement, how we can import the data. So import the pandas as PD, then df is equal to pd.read underscore CSV, and this is the file name you will put here. Then you will check the handle the missing values. And before that, you will use some statistical analysis. Okay, and you will understand the data size, how many variables are there, how many values are missing, okay, how many values are duplicate entries are there. So for that, you will handle the missing values. You will we have some operations, and I think we have discussed all these operations. If not, don't worry. Okay, this will, when we will start to work on the real data set, you will understand how we can implement all these operations. This is not a big problem. Okay, but you are familiar. In the previous session, we demonstrate how you can use the read the CSV file, then how you can apply the statistical operations. Okay, so the last two sessions you have covered this part. Visualization is also the one of the part statistical operations we have discussed. Okay, so the content which I have shared with you, I hope and I trust that you have completed this file which I share with you. If not, then you must complete. Okay. So the next we have is the remove the duplicate value. If there are some duplicate entries are there, identify and remove the duplicate rows to avoid bias. Bias is just like some of the you can say if the same entry is repeated, that can increase only the complexity. Time span will increase. Okay, and there is no meaning of the any duplicate entries. Okay, so just 1 minute. Okay, so next we have the just 1 minute. Okay. One minute, please. Okay. So is 1 minute, 1 minute. Okay. Yes, I was talking about the encode. So encode sometimes when we have the data set containing just like gender, we have male and female. But when we are required to implement statistical analysis or we want to implement machine learning model, okay. So male and female, the non-numerical values are not applicable. We have to convert them in numerical value. So just like you can see here, male we can convert in, we can use for male 0 and for female we can use 1. Okay, sometimes we have the multiple categories. Okay, just like good, very good, bad, worst. Okay, so 4 categories are there. So we can use 0, 1, 2, 3 for them. So that we can easily implement the model. And then we have the feature scaling. Okay, so feature scaling means sometimes the data contain the numerical values and there is very large difference in the smallest and largest value. Just like if the smallest value of the income is 20,000, some can have 50,000, 80,000. Okay, 1 lakh, 2 lakh, 3 lakh. So to reduce the complexity in the computing, what we can do, we can scale just like by using the minimum max operation. So this will be x minus minimum upon maximum minus minimum value. So by using all the values will be converted which lies between 0 and 1. The maximum value will be 1 and minimum value will be 0. So by using this operation, we can scale the values. So there will be no impact of the output. That will be remain same, but the complexity will be reduced and performance will increase. And then we have the feature selection. Okay, so select the important feature and remove the irrelevant ones. Just like sometimes feature selection, we can see the feature engineering also. Okay, so select the important feature and remove the irrelevant ones. Sometimes in our data set, all the variables are not relevant to the output. So by using just like we are applying correlation. Why we are using? To understand the data set, to find out the relevance between the two variables, whether they are affecting or not. Okay, if there is any variable which is not associated with the other and there is no effect, we can remove them. And one is the feature engineering. Just like you can see, I think this is the next part. Yeah, there is in the next part. So after that, what we do, we will divide the data set in two parts to train the model. So here you can see this is the min max scalar. By using we can do this part, and for the feature selection we will use this select k best and RFA. So these are the Python input which we can use for the feature selection if it is required. Then we are required to separate the data set in two part. This is very, very important. Actually, the problem is we want to train the model and also we need to test the model by using the same data set. Okay, so for that large part of the given data set or whatever we have, we will use it to train the model. And the small part of the data set we will use for testing the model. Okay, so mostly what happen if you are using 70% data set to use for training, the 30% will be used for testing. If you are using 80% for the training, 20% will be for testing. If you are using 90% for the training and 10% will be for testing. Okay, so most of the models which we have trained, we always maximum time examples you can find. This is the way train underscore test underscore split. Test size we are using 0.2. 0.2 meaning 20%. So the 20% data is used for testing, test size. Okay, you can see this is the test size. So this is the small part from the data set. Okay, so 20% data set is used here for testing and 80% will be used for train. Okay, so all these features which we are using here in this slide which we discuss will help us to improve the model accuracy, reduce the training time, reduce the overfitting and errors, and ensure data consistency and better prediction and insight. So that's why we need these operations to make more accurate model. And here in this slide, you can see. So here is the feature engineering that is very, very important part. And one participant, I think yesterday or back day, asking about the feature engineering. So here is the example. And these operations we can apply. Okay. Do you have any question, please? Do you have any question?
No, sir, it's clear.
Okay. Thank you. So yes. So here you can see this is the original data set. I think we have used this operation yesterday when we are using the healthcare data set. There was in the last column we get the days duration of the patient, how long the patient stayed in the hospital. So there are two dates was mentioned there. One is the date of admission and the second is date of discharge. So these dates are irrelevant, not important for us. When we will develop the model, if we have the time duration, how long they stay, number of days, number of years, number of months, these are important for us. So from these dates, when you are converting for the to get a number of days Okay, as we do in the healthcare data set. Okay, new variable is there. So this is the example of feature engineering. Okay, here you can see on the left side the table, this is the original feature. Features are date, salary, age, and on the second column you can see date are there. Then we have the salary 55,000 numerical value. Full date is there, and at the bottom you can see the age. This is the numerical values. So this information is there in our data set. When you will apply the feature engineering, what you can do, if dates are there, we can convert with the help of dates in the month. Okay, we can convert in the years, depend upon the prompt. Okay, don't take the example of the healthcare data set. Okay, the patient will stay for only days or maximum month or 2 months. Okay, so very rare chance to stay in the hospital for 1 year. Okay, so but if we have some time series data set, we can do it like in this way. Okay, in the months, in the year, just like we have a 5-year data set. So dates are mentioned there. You can convert a month, year. So this will help us. And there is salary. So salary is a numerical value. Okay, but if the range is varies from 10,000 to 90,000, big difference. We can divide in a high level, medium, low. We can convert in the group. We can fix the range. Similarly, for the age group, okay, age can vary from 10 to 90 years. Okay, we can convert in the small group, just like 20 to 30, 30 to 40, and 40 plus. Okay, 3 groups are there. So this group, we can easily train the model. Okay, we have only the 3 values by using in this way. We have 3 unique values, and here all the values can be different. If we have 10,000 data set, and if the age is different, okay, so some of them can be repeat, but the unique values can be 500, can be 200, can be 100. Okay, but here we have only the 3 values. Okay, here the salary can be varies from 10,000 to, if we have 90,000. Okay, there'll be various type of the variations can be there. Okay, so we can divide in the 3 categories: high, medium, and low. Okay, you can take some more group, but if you will convert this data in this way. So these type of the operations are feature engineering, and by using these feature engineering, what are the benefit? Number one, better accuracy. Relevant features help the model learn the right pattern and improve the prediction accuracy. Then faster learning, well-engineered feature reduce the complexity and help model train faster with better convergence. And last one, reduced overfitting. Okay, meaningful features reduce noise and redundancy, leading to the better generalization. Okay, so these are the main features. So from the raw data, you can see we can apply the feature engineering just like transform, create, select the most useful features which we can discuss here. And there are various type of the feature engineering operations are there. According to our prompt, we can use one of them. Okay, then we have the, after applying, we can have the better model, more accurate prediction, faster training, better real world performance. Okay, then we can have the, this is the most important part. If you will perform all this, then this is the level. Okay, this is the trend test. Okay, so here the example is, I told you that when we will apply the machine learning model, never be tested on trend data. Okay, so what do we do? We have to split the data set into part as we discussed, 80% and 90%. 80% will be used to train the model and learn the pattern. 20% will be used to evaluate the model's performance on the unseen data set. Okay, so when you will split, just like you can see at this middle, this is the original data set. So this part you can see this is the 80% data set, and the 80% data set from the existing data set or the historical data set, this will be taken randomly. Okay, this is not mandatory that the first 80% or last 80% or 80% from the middle will be taken. No, the 80% will be used from the entire data set randomly. Okay, some of the values will be missed, which will be 20%. So on these data set, we will use the model to train, and the remaining data set which is unseen or which we are not using, that is 20%. This is 20% data set will be used for testing the model to evaluate. Okay, so here when you will apply the Python programming, we are required to import here sklearn.model_selection, import train_test_split. Okay, so this function, actually there is a scikit-learn library which we can use for machine learning models. All type of the machine learning model, we are required to import machine learning library, and from that we will choose different algorithms as well as different operations which we are required one by one. Okay, which we will cover in the coming session practically. Okay, so this is the way: xtrain, xtest, ytest is equal to train_test_split. This is the function which we import here. Okay, the same we are using here. So the entire data set will be divided into two parts. One is x and other is y. For test, we are using 0.2, and random state we are taking 42. So don't worry about the value 42. For the random state, meaning is ensure the reproducibility of the result. Okay, so when you are using the 0.2% data for testing, so the result every time when you will have the output, so the output can remain same. Okay, so at the place of 42, you can take any value, just like 1, 2, 3, 4, 5, up to 100. You can take any range. There only we need numerical value, not negative. Okay, so this is the way which you will apply the Python code. So why split? Prevent the overfitting, ensure the model generalize well to the new data set, and realistic evaluation perform on the unseen data set, better prediction to more accurate and reliable. Okay, efficient use of the data, make the most output of the limited data set. Okay, so this is the pie graph you can see here, 80% and 20% ratio. Mostly we are using. Then these are the some models which we can use for training purpose. Okay, so I think all of you are very familiar about regression. Okay, so when you will use this regression model, this also will be based on one of the example of the machine learning model. Okay, so scikit library we are required to use, and we will call the regression model. Okay, so here we have the example of finding the best fit line, so that we can predict the future value. So the regression is a supervised learning technique used to predict the continuous output variable based on one or more input features. Okay, so just like we can have the input features, we can have size, bedroom, location, age of a house. So on the base of a house prediction, price of house prediction. Okay, so we can check the size, bedrooms, location, age of the house. These are the input features, and this is the target value or the labeled value. which we know. Okay, on these features, we know the price of the code. Okay, because when we have the data set, we will train. So this is the some algo. So by using the algo, we will train the model. We will establish the, we will fit the model. After that, we can use for the future prediction. Okay, so why use regression? Predict context values, find the relationship between the variables x and y, how they are changing. Okay, so as you can see here, we have the scatter plot and this is the straight line, linear line you can see. After applying the model, we have this line. Okay. So useful for the forecasting and trend analysis, widely used in the real world application. And these are the types. Linear regression is there. We can have y is equal to beta naught plus beta 1x plus error. Okay, polynomial regression, you can have y is equal to beta naught, beta 1x plus beta 2x square plus and so on, beta n xn plus epsilon. Okay, so then we have the rigid regression. You can see here we have minimum y minus x beta square plus lambda. These are the definitions and the formulas for their respective different algorithms or the techniques. Okay, rigid regression, then we have the lasso regression. And most of us, we are familiar about the first two categories, linear and polynomial. Okay, this is the part when you will apply any algorithms, you will have some output. Now it is the part to check whether our model is accurate or not. The values are producing which how much these model are accurate. For that, we have the formulas, mathematical formulas we have put here. Okay, so yi is the actual labeled data. And yi cap which we are using here is predicted value. Okay, I am audible?
Yes, sir, clear.
Okay. Okay. So, yes. So these formulas will help us to check the, actually, error means, what is the meaning of error? Error is the just difference between the actual target value and predicted value, difference between these two terms. Okay, so the difference between the actual and predicted value. So if you are using MAE, mean absolute error, so the formula is 1 upon n summation I is equal to n. Yi, this is the actual output. Yi cap is the predicted value. So our main purpose is to reduce this error. And on the basis of the values which we are getting, this will let us know how much our model is accurate. We are required to use mean squared error. Okay, we can use RMSE, root mean squared error, and we can use R square. R square is highly useful. Measure goodness of the fit. Okay, so according to the need, so when we have the real problem, then you will be better understanding about these applications. Okay, so now you can have the next one we have is the linear regression. Okay, so the linear regression model, the relationship between the two variable, one is dependent and other is independent. Okay, or more independent variable we can have by fit a straight line to the data set. Okay, so here we can have x variable and y variable. Okay, so this is the independent and this is the dependent. And you can see the scatter plot here, and this is the linear regression line. the equation which you can see here, y is equal to mx plus c, and we all are familiar about this line. Okay, a line of equation of the line. Okay, so x input variable, y target value, m is the slope of rate of change, and c is the intercept on y-axis. So this is the Python programming which you can see here on the right hand side, how you can implement. Okay, this is the way. So how it work? First, we are required to collect the data, then find the best fit straight line, then minimize the error. Residue. Error means residual. Sometimes we are using residual term. Okay, the residual means we have to reduce the error between actual value and the predicted value. Just 1 minute. Okay, so yes. Our to train and to reduce the error, because we have to test how far is our predicted value. Okay, so as much we reduce the error, okay, we have more accurate model. So this error we are required to remove, and for that we have to check by using this test. Okay, this test will let us know how much our model is accurate. Okay, so then when the model is trained, we can use for the prediction. So this is the example which we have given, and we have done. You can easily understand this example. These are the application part where you can use the sell prediction, price prediction, demand prediction. Okay, very simple. Then we have the other model, which is classification. Okay, this we can use when we have the categories or class labels. Someone has unmuted the mic. There is any question, please? Participant, please mute your mic. Okay. Noaita Singh, please mute your mic. Noaita, please mute your mic. Thank you. Just 1 minute. 1 minute, please. Okay. So here we have the classification, right? So the examples which you can see for spam or not spam, this is healthy, pass fail, fraud, genius. So these are the some examples where we can apply. So how the classification will do in the very first step, you can see in this box, we have three colors are there. Okay, this is the raw data with non-labels. Okay, just like labels are the only color, red colors are in the square form, and green are in triangle form, and blue colors are in circle form. Okay, so we will apply here some algorithm, and this will understand the pattern inside this data set. Okay, this will classify in three categories according to how type of the data is there. As you can see here. Okay, the blue color is here is green color, and here is red color. So the model finds the best decision boundary. The lines which you can observe here, this line and this line, these are the boundaries of the data set, and in three categories this will be segregated. Okay, and on the basis of these three categories we have the prediction on the unseen data set. Okay, so a blue color is in class A. Okay, and just one minute. Okay. Yes, and green is class B, red is class C. In this way, we have the data is when new data is come. So according to the new data, pattern will automatically predict the value. So whether it is belong to class A or class B or class C. Okay, so here is the types of the class. So you can see binary classification, we have only two categories. Okay, just like a spam, not spam, pass, fail. Okay, true, false. We have only two categories, and one is on the upper of this line, and the other is on the other side. But sometimes we have the multi-classification when we have more than two. Okay, so we have the boundaries between the different data set, as you can see in this image. Okay, then these are some applications we can apply this technique: email filtering, fraud detection, medical diagnosis, document classification, sentiment analysis, and customer segmentations. And these are some popular algorithms which we can use for classification. Okay, so you can see the logistic regression. A decision tree, we can have split data into the branches based on feature. KNN we can use. Okay, classified based on the majority class of the nearest neighborhood. Okay, which is known as K nearest neighborhood. And then you can say we can have the naive based. Okay, use probability to classify based on bias, or we have studied during our course in lower class. Okay, then we can have the random forest, and last one we have is the SVM, which we can use for finding the optimal hyperplane that best separate the classes. Okay, so when we have a three-dimensional data set, in the case we can use SVM, and random forest we can use example the decision tree for better accuracy. Okay, so sometimes when you are using decision tree, but sometimes not give us accurate. So we can use random forest for the better output. So this is the logistic regression. Actually, some of the overview we must have about the models which we are required to use in our machine learning model. Okay, so that when you will apply, okay, sometimes all the information we not able to keep in mind at once, but when you will use, at least you must have the information when and which type of the model we can use. But all these operations and the expressions which you can see, all these will be because we are required to only use model. So all these operations which you can see here, we are not required to calculate. The model will automatically do everything which we need. Okay, but if we have some basic information and which type of the model we can choose for right choice according to our data set. So the understanding about all these must be clear. So what is a logistic regression? Logistic regression model the probability that a given input belong to the certain classes, like input feature we have is the X and the probability 0, 1 or class 0 or 1. So here we have two things. One is the probability and one is class. Okay, class means true, false. Okay, so according to that we have two values, probability and class. Actually, for that we are required a sigmoid function. Okay, uh, we can have various type of applications in the deep learning of the sigmoid function. One of the, we can say, the activation function, but here we have different purpose to use here. Okay, just like you can see this part. If the probability, actually the values when you will use the sigmoid function, okay, z 1 upon 1 plus e raised to power minus z, and the value of the sigmoid function you can see lies between 0 to 1. Okay, so but we need either 0 or 1. For that, you can see here, if the probability is greater than and equal to 0.5, class is 1. If the probability is less than 0.5, class is 0. Okay, so here is class 0 and class 1. So this point, this value will decide, okay, whether the value is on the left hand side or on the right hand side. Okay, according to that, we have these two classes. Okay, so here you can see we have the input features, then we have the linear combination z is equal to mx plus c. Okay, this is the sigmoid function. So sigma, this value will pass through here at its place. Okay, and this will compute the value. Probability is 0 or 1. Okay, suppose that it is 0.23. So this belong to 0. Okay, so this is the way how we can decide how these values will occur. Okay, so here you can have the algo. Okay, how you can use in Python implementation. So here the model you have to import logistic regression, you can see here. Then you will use the model logistic regression. Then after you will fit the model dot fit x train y train, and then predict model dot predict x test, and then print the prediction. So this will return the prediction. And after that we are required to check the accuracy, and these are the applications, disease prediction, email spam detection, credit approval, etc. We can use this part. Okay, so these are the logistic regression. What are the purpose where we can apply and how we can do. But for our purpose, this part only. Okay, sometimes there are various type of the model, and when we implement many times the peoples who are from computer background, okay, mainly they directly work on this part. They don't know much about this information. Very less people are there who try to understand the entire mathematics behind this algorithm. Okay, but in this training program, most of the people are from mathematical background, and if not, don't worry. So this is the mainly mathematics behind. Actually, in AI, ML, in the entire AI, I will say completely artificial intelligence based on mathematics. And without mathematics, we are not able to develop any technique which we are using in our daily life, whether it is a generative AI, just like ChatGPT, Gemini AI, all type of the models which we are using, just like to create the text or PPTs, or to create the song, or to create some like of videos. Behind all these, in the behind, mathematics is there. Okay, so you can see here, these are the some examples where we are using to predict the value. Okay. So here, this is the decision tree. Okay, so how this will work? What is a decision tree? Decision tree is a flow chart like a structure where internal node represent the feature and branch represent the decision rule, and leaf nodes are outcome. Just like you can see, this is the node, and these are the features, and this point which you are observing, these are the leaf node endpoints. Okay, this is the root node. Okay, so according to this, the model will work. For example, here you can see example decision tree. This is the age. The age is greater than or less than greater than 18. Income. If the age is less than and equal to 18, don't buy. If there is income high or income low. If the income is high, buy. Laptop, Apple laptop. Okay, and if income is low, don't buy. Okay, so according to that, that decision tree will work. Okay, so here this is the visualization part. This is the input to yes or no, then B note yes or no. Okay, buy, don't buy, C yes, no, buy, don't buy. So in this way, this will work. And this is a very simple syntax you can see here for to apply using the Python. So what are the advantages to use this one? Easy to understand, simple structure, easy to interpret, and finally you can see everyone can easily understand this part. Fast, quick to train and make the prediction. Handled non-linear data, can capture complex pattern and interpret between the features. Okay, so here you can see the applications. Okay, so then after we can have last one, K nearest neighbors, and simply we can say KNN. Okay, so KNN predict the class of the data point based on the classes of the fit of the nearest neighbor. What is this one? So actually, we will observe the how far is from the point. So k-nearest is the simple non-parametric instances between algorithms used to classification and regression. So the new data, this is the class A and this is the class B, and distance. So these are the part. So distance will be taken. Just like you can see here how this will work. Here is X and Y. Okay. So select the number of the neighbors, how many neighbors you are taking for any point. Example, K is equal to 5, we have taken here. Okay. Then calculate the distance between the new point and all the trending point. So the common we are using here, including distance. This is the distance formula. Okay. So then after find the nearest neighbor, select the K nearest neighbor, just like this is the point. And these are the values. So which one is the nearest? So here you can see these values in this circle. There are 3 values are nearest in the circle. Only 3 colors you can see. These are the nearest, and these are not. Okay, so nearest point will be taken, and then majority vote is assigned the class that occurs most frequently among the K neighbors, and this will predict the class. Okay, so this is the visual example you can see. This is the target value, and these are the neighboring point. Here are class A, class B. Okay, and the new point is the star. You can see this is the new value, and K equal to 5 we have taken in this point. So among 5 nearest value, which one? Class A. Okay, so class A is these 3 values are nearest. So this is the choosing K when we have the large data set, and according to that we have fit the curve. This is the decision boundary. This is the decision boundary by using this K nearest neighbor technique. And this is the Python implementation. Okay, from sklearn. This is the model. this model we are using. Okay, so when you will implement, we all these we are not required from our data set. We need only this part. Okay, this part we are not required just for the understanding how this is working. Okay, if you need some deep understanding, and if in the future you want to develop some new technique which are more advanced than the existing, then you are required to understand the pattern behind all this, how we are developing the technique, and then you can write your algo, and then you can publicly publish, and that can be used for the new generation. So when you will comes across all this information, you have the deep understanding, understand each pattern, everything. Okay. And in the Python, just we are required this few statement. This we are required to import the KNN classifier. Then you will have to put the model. Okay, how many neighbors we are taking, just like for at this example, we are taking 5. So you can fix the value according to your choice. And when you will do the experiment, you have to change this value. So at how many neighbors your model is more accurate. According to that, you will fix this value. Then model fit and print the value. After that, we have to evaluate. Okay, so when we have the predicted value and actual value, we will apply the test which we have discussed in the previous. So all those tests will be applicable for all type of the model. Okay, model can be different, but technique to evaluate the model will be same. Okay, then these are some applications which you can see here: pattern recognition, recommendation system, medical diagnosis. Okay, so these are various applications, but here we have 3 applications are there. So this is the conclusion. Actually, the main thing is you can see the key takeaways. Data is the foundation. Actually, the everything for every type of the model which you want to develop, data is everything. Without having the data, and as much you have large data set, you have a more accurate prediction. Quality of data and proper processing and lead to the better model. Feature engineering to fit the good features, improve the accuracy and generation, and choose the right algorithm. So we have discussed one of them we have to choose. And after that, when the model is trained, then evaluate and iterate, measure the performance, learn from the error, okay, and keep improving. So improvement is very until we have the error is much small as possible. The goal is impact. So use the machine learning model to solve the real world problems and create the value. So this is the actually the complete workflow. Collect the data, then pre-processing the data, feature engineering, train model, evaluate, deploy, make, impact. So all these we have discussed, and this is the best practice we need. Okay, understand the problem deeply, explore and understand your data, keep your data clean and consistent. All these things we have discussed. Okay, create meaningful features, start simple, then improve, validate your model thoroughly, and then deploy responsibly and ethically. Okay, so when you think that your model is more accurate and we can deploy for the public domain, okay, then we can deploy. But for the deployment, we need to integrate some more skills because this is the part of the development. Okay, we will develop some web application or mobile application where all these things will help. Just like you can see weather prediction model, you can see the model which is implemented on the Amazon website. Okay, for the product recommendation, and then continuous monitor and retrain. Okay, so this is all about myself. But along with first of all, thank you very much to listen my lecture entire and keep in touch till the end till this part. One more thing I would like to share because you are muted, so you are not able to unmute. If you have any question, you can ask from me. Just 1 minute, I have to give you the permission. Only then you can do. Now you can unmute your mic. Okay, one sheet I would like to share where the entire machine learning roadmap is there. Okay, I will share with you. So if you have any question, now you can unmute your mic to ask your query. Renu Bala madam, how are you? Are you there? Okay, sometimes if I am asking, please unmute your mic. Devi Kala. So please let me know everything which I am trying to present here is going well. Because
Yes, sir.
Yes, sir, it's clear.
from your side, no question. I am confused. Whether
Actually,
you are catching everything, whether you are skipping everything. So if you will ask some questions, this is the feedback from your side. If you are replying yes, no, okay, you
sir,
are.
I'm working on feature extraction through machine learning. So I have image data for this.
Pardon?
I
Ma'am, please
have,
repeat. Yes.
hello. Yes, sir. I am working on machine learning through
Okay.
feature extraction, and I have image data for this.
Okay, 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 okay.
Yes, sir. So,
Don't worry, you are at the right place.
yes, sir.
Okay, we will help you and whether this part will be covered or not, but if you have any problem, uh, we will help you. Okay, because
Okay, sir.
1 week is not enough time to cover
Yes, sir.
everything.
Yes, yes, sir.
Okay, but you can have some ideas how everything will happen. But for that, we are required some deep learning concept, image processing. Okay.
Yes, sir.
Yeah, you
My
have image data, right?
my area is texture, color, and shape feature extraction.
Okay, okay, good.
Yes,
Okay.
sir.
So the fundamentals which we have covered are meaningful for you or not?
Yes, sir.
I am asking the content which we present during the today's session, all these are beneficial for you or not?
Yes, yes, sir. Yes, sir.
Okay. So if you have any question or any problem for the other participant also, please don't hesitate. Okay. My session are always open, so you can friendly ask any question from your side.
Okay, thank you, sir.
Thank you, ma'am. Thank you. And Kalpana, madam. Kalpana Suresh Babu. Okay. Yes. Any question, please? So again, I am going to share my screen. And here, okay, just 1 minute, please. Only 1 minute. Yes. You can see this is my this is the roadmap for machine learning, step by step. Okay, so all these steps are required for you. First, we are required to define the problem. Okay, understand the business problem and objective, define the target variable and success criteria, etc. Then we are required to collect the data set, okay, according to our problem. What are the parameters are there? How much data set is required to train the model? Okay, then in the third level, pre-processing the data, handle the missing value, outliers, inconsistencies, perform encoding, scaling, feature engineering, etc. Then EDA, exploratory data analysis, analyze the data to find the pattern, insight, visualize distribution, correlation, and the trend. Okay, some of the part we have covered this one. Then after that, separate the data. So machine learning part start from this place. Okay, so 4 stages almost we have covered. Almost, not everything, but almost we have covered, and we can implement now this part. Separate the data, divide data into the training and testing, as we discussed right now. Okay, then select the algorithm. This is the 6th part, 6th level. Okay, so according to our problem and the complexity, we have to choose the model. Then we have to train the model. Okay, and this part is the evaluate the model, whether the testing using the matrices, check the overfitting and the underfitting we have to check. And if everything is fine and the matrices which we are required are satisfied, then after we can deploy the model. So this is the 9th level. Okay, so this is the complete roadmap, and these are the libraries which we are required to use. At least these are required. Okay, scikit-learn for training the model. Okay, and TensorFlow, Seaborn, and Matplotlib, Pandas we have used. NumPy also. Okay, so this is the regression test which we can use, and these are using for classification. That if your model is based on regression, so these tests are required. Okay, if the model is based on classification, then these test parameters are required. Okay, so everything, the overview about the entire machine learning model, what are the roadmap is there in this sheet. Okay, so I will give you with the presentation. So you must go through about this, and this way, all the entire idea you must have in your mind. So that when you will apply, you must be familiar about what should we do now and what will be the complete process, how you can start. Okay, so everything which is required for the machine learning model. Okay, now you are able to work on it. So I will share the sheet today where some models are there. You can choose according to your interest. And now you will work on it parallel with me. And according to that, you will implement, and you will develop one model, machine learning, for the prediction. Okay, so you can have some real problem, and you will apply from your side also. So the model which I will present here, you will do that one, and the problem which you have chosen for your project. Okay, so all the process which I will do, you will do the same thing in your project also, parallelly. So that, but the thing is, you will not share your title in the WhatsApp group. Okay, so sometimes one model has been taken, the other participant also, so that there can be some conflict. Okay, but you can ask the problem. Okay, so the procedure will be quite simple, and I'm sure you can do. So this is all about the today's session, and if there is any query, you can ask. Okay. So if there is no question, I asked to Faiz. Dear Faiz, you can conclude the session. Faiz, are you there? Okay, I think he is busy. So, dear participant, good night. And tomorrow we will start the session at the same time. And the content will be available in your WhatsApp group. So, do practice on it. So, at least the concept about everything must be clear. Thank you and good night.
Thank